Good day to everyone who's watching. In our lesson 2 of indices, we're going to talk about equations involving the indices and how to get the unknowns when we are dealing with the index numbers. Our example 1, solve for x in the following. Our part A, we have 2 power x is equal to 8. 2 power x is equal to 8. Now, what we do, because the unknown is the power, we are going to express that number on the other side as an index number such that we can easily equate the powers. So our 8 in terms of 2, when you prime decompose, so that one is going to be equal to 2 power 3 there. Now the bases are the same. If the bases are the same, that means that also the powers are the same since there is the equal sign in between them. So this implies that the x is going to be equal to a 3. 3 power x is equal to 2, 4, 3. We are going to prime decompose 2, 4, 3 and we see what we get. When I prime decompose, so the 24, that is 8 and 1. So 81 divided by 3, that one is going to be 27. Then 27 divided by 3, that one is going to be 9. When you divide here, you get 3. When you divide here, you get 1. So my 2, 4, 3 is the same as 3. Because I've been using 3 without, I count how many 3's are there. 1, 2, 3, 4, 5. So it's the same as 3 power 5 there. Then I come and I substitute there. So this is going to be 3 power x is equal to 3 power 5. Now, I'm saying if the bases are the same, that means that also the powers, they are equal. So x is equal to 5 right there. Our part C there, we have at the other side 32 all over the root of 2. We need to manipulate this side such that we can also have there a base of 2. So the other side, the 32 is the same as when you prime decompose it, 2 power 5 all over the root of 2. We said in index form, that's going to be 2 power a half. Now, the other side, we have numbers of the same base dividing each other. We say we are going to keep the base, then subtract the powers. So that is the base is 2, 5 minus a half is equivalent to 2 power x minus 1. So that means that now our power here is the same as the power there because the bases are the same. So that is x minus 1 is equal to 5 minus a half. X minus 1 is going to be equal to this side fractions. The LCM of the denominators is 2. So I have my 2 there, then times 2 here, then times 2 there. So this one here is 10 minus the 2 here cancels to remain with the 1. So when I subtract this side, I'm having a 9 all over 2. So this is x minus 1. Then this minus 1, I take it also the other side. So that's going to be x is equal to 9 all over 2. Then plus a 1 now. Again, I add those fractions there. This one is all over 1. The LCM is 2. This is going to be 9 plus 2. You get the answer as 11 all over 2 as the value of x. So example 2, given that 2 power y is equal to 1 all over 8, find the value of y. I 2 power 2y is equal to 1 all over 8. I'm going to prime decompose 8. we know that 8 is the same as 2 power 3. Now, I'm going to look for ways of taking this base here back to the numerator. Remember, we said if you have a power negative n is equal to 1 all over. This is the concept I'm going to use. This is the a power n, where the n is 3 and the a is 2. So I'm going to write it like that there. So this is going to be my 2 power 2y. It's going to be equal to 2 power negative 3. Therefore, my 2y is equal to the negative 3. Then the value of y becomes negative 3 all over 2. Example 4, solve for m in 81 power 1 plus m then is equal to 27 power negative 3m. So the same concept is what we are going to do. We are going to prime decompose the bases, and if they give us the same base, then we can easily equate the powers. So this is the 81 is the same as 3 power 4, but it has a power of that one there. We said when you remove the bracket, the power will multiply. It's equivalent to the 27 is the same as 3 power 3, then times the negative 3m. So the base now is the same. Now I can equate the powers. So 4 into m plus 1 is equal to my 3 times the negative 3m. When I multiply this side, I'm having negative 9m. When I open brackets this side, I'm having 4m plus the 4. Now when I collect like terms, I'm having 4m plus the 9m. It has been negative this side, crossing equal sign gains the sign of positive. Then the 4 becomes a negative. So when I add here, I'm getting 13m is equal to negative 4. When I divide both sides by 13, I finally get my value of m as negative 4 all over 13. Example 5 there, find the values of a and b if 2 power a times 3 power m is equal to 12. So on the left hand side, I'm having the 2 and the 3 as bases there. So I'm going to make sure that even on the right hand side, I'm having the same bases like this side. So when I prime decompose 12, the smallest prime number here is 2. That is a 6. Again 2. That is a 3. Then 3. That is a 1. So the 12 is equivalent to 2 times 3. But the 2 is appearing twice and the 3 is appearing once. So I substitute there. 2 power a times 3 power b is equal to 2 squared, then times 3 power 1. So that means that the a corresponds to 2 and then the b corresponds to a 1. Because I'm having the same base numbers this side and the same base numbers that side. Therefore, my a is a 2 and the b is a 1. Example 6 there. If that one is equal to that, express p in terms of x and y. So here they want us to get to simplify. Then we see when we are having the same base numbers, then we can now equate the powers there. So the 4 is the same as 2 squared, but there is a power of x. then times 2 power y all over the 2x plus 2y is equal to 2 power p. So removing the bracket here, I'm having 2 power 2x, then times 2 power y all over 2 power x plus 2y is equal to 2p. So dividing numbers of the same base, we shall be subtracting, and multiplying numbers of the same base, we shall be adding. So this left-hand side is the same as 2 to the power 2x plus y, then minus x minus the 2y is equal to 2 power p on the right-hand side. So when I open brackets here, this is going to be 2 power 2x plus y minus x, then minus 2y, then is equal to 2 power p. So when I simplify here, that's going to be 2 power, it's going to be x, that one's going to be negative y, is equal to 2 power p. Now you can see now the base numbers are the same on either sides. That means that the powers are equal. So p is going to be equal to x minus y. So I've expressed p in terms of x and y. In other words, I've made p the subject of the formula.